Okay, so good morning to one and all. In the previous lecture, we have discussed one important type of connection, that is open delta connection or VV connection. This one we have already discussed. In case of VV connection, if three single phase transformer, or by using a three single phase transformer, we have constructed one three phase transformer, and any one of the transformer from that bank, if it is taken for service or it may be it is burst, then remaining two transformer which is able to continue the supply, that means which is able to maintain the continuity of the supply but having an reduced capacity and having an reduced efficiency. Okay, and this capacity it can be reduced near about 57.7%, or it will able to carry a load of 57.7%, that means near about 58% load it will be carried. So this point we have already discussed in the previous one lecture. Now today we will discuss about the next one point, is that the three winding transformer and its equivalent circuit, that is equivalent circuit of three winding transformer. Okay, we will discuss three winding transformer and the equivalent circuit of that three winding transformer. See, first of all we will discuss what is three winding transformer, why it is called as three winding transformer, and what is the purpose of that three winding transformer. Three winding transformer's purpose kai, how it can be constructed, we will show that figure, and after that we will draw the equivalent circuit diagram of three winding transformer. See, sometimes in the high rating transformer, the third winding is constructed in addition with that of primary and secondary. Okay, see, in addition with that of primary winding and secondary winding, another one winding or the one extra winding it can be constructed in case of transformer. So if we required a high rating of the transformer, ज्यावेळेस आपल्याला ट्रान्सफॉर्मरचा हाय रेटिंग रिक्वायर्ड आहे, at that situation we are constructing one of the extra winding or one of the third one winding in that transformer to increase the rating of the transformer. That is, this third type of winding, or this is the third one types of winding, it is called as tertiary winding. Okay, so this winding it is called as tertiary winding, that means along with primary and secondary another one winding it can be constructed, that is another one third one winding it can be constructed if we required a high rating transformer. So this winding it is called as tertiary winding. All of you keep in mind, third winding or the tertiary is nothing but again third, or we can call it as a third winding also, or it is called as tertiary winding. And because of this tertiary winding, the transformer it is called as a three winding transformer. Okay, see, suppose any one of the transformer is there and it is having an primary and secondary winding. Suppose on this one limb we consider one of the limb, on that limb here it is one winding, it will carry a supply voltage of V1, again it is having an another one winding, so it is carrying a voltage of V2, or it will induces an voltage of V2. In addition with this primary and secondary, we are constructing another one winding on that same limb. त्या same limb वरती आपण एक another one winding काय करतो, construct करतो. So it will induces an EMF. Suppose V3 voltage it can be induces by this winding. So this is the extra winding or the third winding, we can call it as a tertiary winding, and due to the tertiary winding it can be connected in transformer. This transformer is called as a three winding transformer. Okay, all of you understood the concept why it is called as three winding transformer. That means in addition with primary and secondary winding. In addition with the primary and secondary winding, the another one winding it can be constructed, that is third winding, it can be wound or the constructed. So this third winding it is called as tertiary winding, and due to that tertiary winding there are transformer, it is called as three winding transformer la three winding transformer month. Okay, now the voltage ratings of all the three winding of the transformer are usually unequal. Okay, see the voltage rating, that means voltage rating or the turns ratio. So each and every winding, that means voltage ratio or the voltage of each and every winding, it is unequal, not equal. So unequal voltage, meaning of that the turns is also unequal, right? No, turns काय असतील unequal असतील, because the voltage of the each and every winding, that is primary winding, secondary winding and the tertiary winding, it is unequal. तिन्ही वाइंडिंगचं जे काही व्होल्टेज असेल ते अनइक्वल असेल. ड्यू टू दिस अनइक्वॅलिटी, so the turns contained in each and every winding, it will also unequal. See how the rating it can be adjusted. See that the primary winding has the highest voltage rating. जी काही primary winding असेल, so this primary winding it is having an high voltage rating, and the tertiary winding which are constructed, that is third one winding, it is having an lowest voltage rating. Okay, and the secondary winding it is intermediate in between that two. That is, see, suppose the primary winding having an voltage of 66 kV, if the secondary winding having an voltage or tertiary winding having an voltage of 11 kV, in between that, that means intermediate, the voltage of the intermediate winding or the second winding or secondary winding is nothing but in intermediate between these two. या दोन्हीच्या मध्ये suppose we can call it as a, it may be a 33 kV, right? So the voltage rating change is nothing but turns ratio change, or it may be turns change, and meaning of that the transformer having an unequal voltages. Transformer it is having an unequal voltages. Okay, getting now what is the importance or what is the advantages of these types of construction? याचं काय advantages असेल? That means we are constructing extra winding, primary and secondary, and another one third winding, that is tertiary winding. We are constructing these three winding, voltage ratio or it may be voltage of each and every winding, it is unequal. So again the range it can be decided, the primary winding having an highest voltage as compared to that of other two winding, and the secondary winding it is having an low voltage as compared to other two winding, and the tertiary winding it is having a lowest voltage rating, and the secondary winding it is having an intermediate voltage rating between that. Okay, so what is the advantages of this? Is nothing but the cheap advantages of the three winding transformer is an economy of construction, and due to that economy of construction also it is having an greater efficiency. Okay, see these types of transformer, that is three winding transformer, is an economy of construction मध्ये economy or economical while constructing as compared to other transformer, and it is having an efficiency is also greater efficiency. So these are the important two advantages, like it is having an economy of construction, it is having an economy of construction and efficiency of these types of transformer, it is nothing but greater efficiency. Okay, see the schematic diagram I have already shown, but I will show the diagram also, that is schematic diagram of three winding transformer. See here, same diagram I have also drawn here. but for our understanding purpose, again here are one 3-winding transformer. It can be constructed. Suppose this is a one of the limb of the transformer. On that limb of the transformer, all 3 windings are constructed like primary winding, secondary winding, and the tertiary winding. That is, we can call it as a third winding, or it is nothing but tertiary winding. So because of this 3 winding, or because of the third winding, we can call it as a 3-winding transformer. We can call it as a 3-winding transformer. And again, see the turns of the primary winding, turns of the secondary winding, and turns of the tertiary winding. So these are the unequal number of turns. Due to that unequal number of turns, the voltage of the each and every winding, it is also unequal. That is, voltage rating, it is unequal, and the voltage rating priority is given. So primary winding having an highest voltage rating, tertiary winding having an lowest voltage rating, and the secondary winding having an intermediate voltage rating between primary and secondary. Primary आणि सेकंडरीच्या मधलं जे काही व्होल्टेज असेल, that is intermediate voltage rating, it can be achieved in case of secondary winding. Okay, so this is the 3-winding transformer, just schematic diagram of 3-winding transformer. 3-winding transformer ची schematic diagram. Okay, see now, so all of you understood this concept related to 3-winding transformer? Yes, give me reply. What is the 3-winding transformer? All of you understood, no? Why it is called as 3-winding transformer? It's very simple. Just give me reply. Give me reply. Anyone? No one is giving reply. All of you present, no? Hello? All of you understood concept of 3-winding transformer? Why it is called as 3-winding?
Yes.
Okay. See, it is having an extra winding, or it is nothing but third winding. We can call it as a tertiary winding. And due to that tertiary winding, this is called as 3-winding transformer. Again, voltage priority is given. And the advantages I have also tell, that is economy of construction, and it is having an greater efficiency. So diagram for that construction, it is shown in this figure. Now, the most significant advantages of this 3-winding, or it may be third winding, is that what is the advantages of this third winding, or why we want to introduce this third winding. So that means the most significant advantages. So most important or the most significant advantages of the third winding is that the harmonic generated by the primary and secondary winding extinguished by the third winding. Okay, so do you know that there are some of the harmonics component? That means at the time of telling different types of connection of transformer, I have tell that the odd type of harmonic always produces in case of transformer, that is odd harmonic is nothing but third harmonic, then fifth harmonic. In that odd type of harmonic, the third harmonic it is sever, or it may be it is more occurring. Okay, see, so that the most advantages of these types of third winding, or it may be these types of connection, is that याचं जे काही मोस्ट इम्पॉर्टंट ऍडव्हान्टेजेस असेल त्या थर्ड वाइंडिंग चे, इज दॅट the harmonic generated by the primary and secondary winding, it can be extinguished by the third winding, or it can be neutralized by the third winding. थर्ड वाइंडिंग काय करेल, जे काय व्होल्टेज प्रोड्यूस करेल, ओके, so this voltage it will be, or this EMF it will be neutralize the effect of harmonic. हार्मोनिक चा जो इफेक्ट असेल, harmonic content is nothing but there is a distortion of flux, it will be occur, or it may be there is a distortion of voltage, it will be occur. This effect it can be neutralized by using the third winding. So this is the most significant and most important advantages, that is significant advantages of the third winding is the harmonic generated by the primary and secondary winding, it can be extinguishes by the third winding, and the third winding is connected in delta. So third winding it can be connected in delta, so that it will neutralize, or it may be it will extinguish the harmonic generated by the primary and secondary winding. Primary and secondary winding पासून जनरेट झालेले जे काही हार्मोनिक कंटेंट असतील, so this harmonic it can be extinguished. What is mean by extinguished? So this concept it is related to arc extinguishing. Arc is nothing but ARC. Arc. In Marathi, arc is nothing but आपण थोडक्यात ज्वाला म्हणतो किंवा जाळ म्हणतो. So while opening of the circuit breaker, there is some of the arc it will be formed due to high voltage, and the circuit breaker it will be start opening due to high voltage. The air gap between the this two rod, or it may be two electrode, it get ionized, and some current it will be start flowing from that air, and the arc it will be formed. Arc, meaning of arc is nothing but sparking, किंवा जी काय स्पार्किंग झाल्यानंतर ज्वाला फॉर्म होतात, इट इज नथिंग बट आर्क. and extinguishing is nothing but we want to extinguish that arc, म्हणजे जी आर्क आहे ती विझवायची. So according to there are types of circuit breaker is there. In case of switchgear equipment, there are different types of circuit breaker, depends upon arc extinguishing, how the arc it can be extinguished. Suppose arc it can be extinguished by using a ear, so this types of circuit breaker it is called as ear circuit breaker. If arc it can be extinguished by using a vacuum, so this types of circuit breaker it is called as vacuum circuit breaker. If the arc it can be extinguished by using an another one gas like a SF6 gas, so the circuit breaker it is nothing but SF6 circuit breaker. So this part we will this part in your switchgear protection subject you will better understand in that subject. So see, extinguishing is nothing but neutralization, or it may be this effect it can be neutralized, or आपण arc च्या फॉर्म मध्ये कन्सिडर केलं, in Marathi we can call it as arc विझवणे. Okay, so it is nothing but extinguish. Primary and secondary winding generate some of the harmonic, and this harmonic it can be extinguished or the neutralized by using the third winding. Okay, and the third winding it can be connected in delta. See, the voltage of the tertiary winding it will be differs than the primary and secondary winding. As said earlier, the voltage obtained in case of these two winding it is unequal voltage. याचं जे काही voltage असेल, this voltage is nothing but unequal voltage, and due to that unequal voltage, tertiary winding having an low voltage as compared to primary and secondary, and primary having an highest voltage rating as compared to secondary and tertiary. Okay, so as we know that the tertiary winding having a low voltage, so it will offers or it will differs than the primary and secondary. Obviously it will be less, that means it is different from that of primary and secondary. Thus it is used for supplying the power to the auxiliary appliances like the fan, tube lights, etc. Okay, so see, this voltage like a tertiary winding voltage, it can be used for applying the power to the auxiliary appliances like fan, tube lights, etc. of the substation. Okay, suppose in the substation if we have used a 3 winding transformer, सबस्टेशन मध्ये आपण जो काय एक 3 वाइंडिंग ट्रान्सफॉर्मर कन्स्ट्रक्ट केलेला आहे. as we know that voltage rating of this transformer it is different and it is less than that of 2, या दोन्ही पेक्षा काय असेल, लेस असेल. सपोज this winding it is having an 440 volt, this winding is having an voltage of 11 kV, so less than that suppose this winding is having an voltage of 230 volt, right? No, if the voltage of these types of transformer it is nothing but 230 or it may be 4. So suppose this is a 230, third winding it is also used for supplying the power to that of appliances like a fan, tube light in the substation. सबस्टेशन मध्ये जी काही यूज केलेली ट्यूबलाइट असेल, फॅन्स असतील, or it may be some fans for operator, that means ऑपरेटर रूम मध्ये जे काही कूलिंग साठी फॅन असतील किंवा ऑपरेटर साठी जो यूज केलेला फॅन असेल, or it may be some of the fan it can be used to transformer cooling also. So such a load it can be fed by that tertiary winding. Okay, हा जो काही लोड असेल, that means these appliances it can be run on the voltage generated by tertiary winding. Okay, now see some of the application of this third winding or it may be tertiary winding. Tertiary winding it is used for the following application. Tertiary winding it can be used for a following application. So see, the reactive power is supplied to the substation with the help of tertiary winding. Reactive power it can be supplied to that of substation with the help of tertiary winding. That means by using a tertiary winding we can able to feed a reactive power to the substation. Do you know that there are two types of power? That means there are three types of power. One is active power, second one is reactive power, and third one is apparent power. I think you people know the power triangle. तुम्हाला माहिती आहे का power triangle? Can anyone? Anyone knows the power triangle? You have already studied in B-triple-E subject. B-triple-E मध्ये power triangle होता बघा, impedance triangle आणि power triangle. Do you know that the formula S is equals to P plus JQ? It is the power formula. So here the P is nothing but real power, or we can call it as the active power. त्याला real power म्हणतो किंवा active power. Q is nothing but it is the reactive power, and the S is nothing but total power, or we can call it as the apparent power. Okay, ठीक आहे असेल apparent power असेल. So see the reactive power. See, I will tell difference between that. Suppose any one of the generator is there, and this will generate some of the electricity, and this electricity it can be fed by any one of the substation. Consider the substation. Can anyone tell me how the power it will be flow? कशी power flow होईल? Generator to the transmission line, or it may be load. Consider करा एखादा जनरेटर आहे, त्याच्या थ्रू लोड कडे पॉवर फ्लो होते. सपोज इट इज अ लोड having and some of the transmission line. Suppose the transmission line distance is nothing but 1 kilometer. 1 kilometer distance ला ते काय होते, ती power fed होते. So see, tell me the power direction. Which power it can be flowing from generator to load? Or all power it can be flowing from generator to load? Okay, this concept it is in details in your switchgear subject. See, the active power, it can be flowing from generator to load, and for the compensation there are reactive power, it can be fed from load to generator. Okay, so the addition of that is nothing but total power fed by generator is nothing but S is equals to P plus JQ. It is nothing but complex power. So complex power, we can call it as the apparent power also. I think you people know the power triangle. It will be like this. Okay, here it is apparent power, here it is real power, and here it is reactive power. Right? No, I think you people know. So see, reactive power, it can be supplied to the substation with the help of tertiary winding. That means by use of tertiary winding or with the help of tertiary winding, we are able to feed the reactive power to that of substation. Now next one, the tertiary winding reduces the impedance of the circuit. So see, again one of the application and advantages is that the tertiary winding, it can be reduces the impedance of the circuit so that the fault current easily passes to the ground. Okay, due to that tertiary winding, it will reduces the total impedance of the circuit. Circuitचा जो काही impedance असेल, so at that situation it will reduces the impedance. If the impedance it is less, ज्यावेळेस impedance less असेल, whether there is a current, it will be flow more or it may be less. Impedance less. What is the relation? Current it will be flowing from more, no? कमी impedance आहे याचा अर्थ करंट जास्त आहे का कमी? That means it is allowed to flow maximum amount of current, so that if the fault occur, that means if the fault occur, at the fault occurring condition, we know that due to that fault there is a maximum current it will be flowing, and so maximum current it will be flowing, this current it will be directly grounded. Okay, and again there is a low impedance, so that this current it will be directly grounded suddenly, so that there is no harm to that of equipment, or it may be there is another healthy part, or it may be healthy part of the system, it will be as a healthy from that faulty part. Okay, now it is used for testing of high rating transformer. Okay, so if we want to do the test of high rating transformer, then it is very useful. That is this 3-winding transformer, it is useful for testing of high rating transformer. So these are the some of the application of that of 3-winding transformer. या 3-winding transformer चे काय ते application. Now see here the transformation ratio, it can be derived here, that is V2 divided by V1, it is equals to T2 divided by T1, or V3 divided by V1, it is equals to T3 divided by T1. According to this, do you know that voltage ratio, it is equals to turns ratio? We can write V2, that is secondary divided by primary, na? V2 divided by V1, it is equals to turns T2 divided by T1, or we can write V3 divided by V1, it is equals to T3 divided by T1. According to this, we can write, as we know that V3 divided by V2, it is equals to T3 divided by T2. We can write this also, because we know that if the A is equals to B and B is equals to C, that means A is indirectly equal to C, like that. Okay, so see, V2 divided by V1 is equals to T2 divided by T1, and V3 divided by V1 is equals to T3 divided by T1. Turns ratio are equal. So according to this, if we write this equation in the form of turns ratio and current, do you know that the current, it is proportional to the opposite? That means I1, it is equals I1 into T1, it is equals to I2 into T2. Do you know that? Do you know that T2 divided by T1, it is equals to I1 divided by I2. I1 divided by I2. If we do the cross multiplication, that means I2 into T2, it is equals to I1 into T1, right? No, I1 into T1 is equals to I2 into T2, like that I3 into T3. Okay, so this is the turns ratio formula, or we can call it as a transformation ratio of the three winding transformer. हा three winding transformer चा काय असेल transformation ratio. Okay, all of you getting three winding transformer and what are the advantages and application of these types of transformer? Give me reply immediately. All of you getting, no? लक्षात आलंय का?
Yes, sir.
Okay. Now see, we will discuss the equivalent circuit of a three winding transformer. Now, how the equivalent circuit it can be derived, or it may be how the equivalent circuit it can be represented in case of three winding transformer. See, the equivalent circuit of the three winding transformer can be represented by the single phase equivalent circuit as shown in this figure. Okay, see, it can be considered a single phase equivalent circuit, or it may be single phase circuit, and according to this we are able to deriving a three winding transformer equivalent circuit, which is shown in figure, wherein each winding represented by its equivalent resistance and reactance. सो प्रत्येक वाइंडिंगचा जो काय इम्पिडन्स आहे, that means it can be represented by its equivalent resistance and reactance. So do you know that the resistance and reactance, it is nothing but impedance. Resistance and reactance is nothing but impedance, that is Z is equals to R plus JX. So this we have represented by a Z. Z is nothing but impedance ना किंवा त्याच्या resistance ना आणि reactance ना represent केले. All the value are reduced to the common rating base and respective voltage base. Okay, so this all the value of impedance, that is all the value of reactance, all the value of resistance, or it may be all the value of impedance. This it can be represented by a common rating taking a base value. So that means these are converted into per unit value. Now concept related to per unit value. This concept it is in the power system 3 subject in the details. So that means we are converting our real value of impedance, we are converting our real value of resistance, or it may be reactance, into a per unit value by considering any one of the base value. एक base value आपण consider करतो. By considering that base value, we are converting this real value of impedance into a per unit value, and this can be used for deriving a equivalent circuit. ही value आपण equivalent circuit derive करण्यासाठी use करतो. So see, all the value are reduced to common rating base and the respective voltage base. Okay, so base value use करून आपण काय करतो, त्याचं the value it can be represented in the per unit value. Now see, the subscript 1, 2 and 3 indicate the primary, secondary and tertiary respectively. See here, in case of equivalent circuit, there are three winding, you people know. So for three winding, first one impedance Z1, it can be represented for a primary winding, Z2 it can be represented by secondary winding, and Z3 it can be represented by impedance of third winding. Z1 impedance of primary winding, Z2 impedance of secondary winding, and the Z3 impedance of tertiary winding. So we are using here suffix 1, 2, 3. 1 primary, 2 secondary and 3 tertiary. Again, in case of voltage V1 is nothing but primary winding voltage. Voltage V2 it is nothing but secondary winding voltage, and voltage V3 is nothing but tertiary winding voltage. And one of the common point is given here. Similarly, we have represented the current, that is current flowing from primary winding is nothing but I1. So these all terms are taken as a vector, that means considering magnitude as well as direction. आपण याच्यामध्ये magnitude and direction पण consider केले. Now see see, the I1 current is nothing but current flowing from primary winding. I2 bar, it is nothing but current flowing from secondary winding, and I3 bar, it is nothing but the current flowing from tertiary winding, or it may be third winding. Now see, for the simplicity, the effect of the exciting current is ignored. Okay, so for our simplicity, there is a excitation current is there, or we can call it as a magnetization current is there, magnetizing current, or it may be excitation current. Okay, so this current we have taken negligible for our simplicity. Okay, so in case of equivalent circuit, so it may be noted that the load division between the secondary and tertiary is completely arbitrary, and three external circuit are connected between terminal 1, 2 and 3 respectively. Okay, see, the load, how the load it can be divided, that means load division between the secondary and tertiary. सेकंडरीचा आणि टर्शरी वरती जो काही लोड आहे, so this load it can be divided, or it may be division can be done between secondary and tertiary. So this division, it is nothing but it is a arbitrary division, so taking an arbitrary constant, or it may be arbitrary division. Okay, so it is completely arbitrary, and the three external circuit are connected between terminal 1, terminal 2 and terminal 3. Suppose separate load, if we are considering, from terminal 1 to neutral we are connecting one load, from 2 to neutral we are connecting load, and from 3 to neutral we are connecting load. That means these three terminal it can be connected to the load, because there is one common terminal is there, a common terminal घेतलेला आहे बघा, so which is labeled by 0. Since the current, if the exciting current it can be neglected, if the exciting current it can be neglected, so sum of all the current meeting at a junction point, it is equals to 0. So it is nothing but balanced current, like I1 plus I2 plus I3, it is equals to 0. So see, suppose if we are applying KCL at the nodal point A, this is the incoming current, these two are the outgoing current. So sum of the incoming current or summation of all the current meeting at a junction point, it is equals to 0. Or we can call it as a statement that incoming current is equals to outgoing current. So incoming current suppose taken as a positive, या टर्मिनलला येणारे करंट आपण पॉझिटिव्ह कन्सिडर केले, आणि करंट फ्लोइंग फ्रॉम अवे फ्रॉम द जंक्शन इट इज नथिंग बट टेकन ॲज अ निगेटिव्ह. सो इनकमिंग इज इक्वल्स टू आउटगोइंग, दॅट मीन्स इक्वेशन बिकम्स I1 is equals to minus I2 minus I3. So see, shift these two term into left hand side, equation becomes I1 plus I2 plus I3, it is equals to 0. Or first one statement, that is summation of all the current meeting at a junction point, it is equals to 0. That means I1 plus I2 plus I3, it is equals to 0. तिन्ही current ची sum काय येईल? 0 येईल. That means balanced current is there. Okay, so see, the impedance of the figure can be readily obtained from three simple short circuit test. Impedance जो आहे, all three windings are, so this impedance it can be calculated from a three simple short circuit test. That means we are connecting short circuit test, and we are finding the short circuit impedance. In case of transformer short circuit test, ट्रान्सफॉर्मरच्या शॉर्ट सर्किट टेस्ट मध्ये आपण इम्पिडन्स फाइंड केलेला होता. इफ यू पीपल remembering this, then we have calculated the short circuited voltage and we have calculated the short circuited current. ISC and VSC we have already calculated in case of conducting a short circuit test. At that situation, we are able to calculate ZSC. ZSC is nothing but short circuit impedance. It is nothing but VSC divided by ISC. Short circuit voltage divided by short circuit current. So according to this, we are able to calculate the short circuit impedance. Okay, so see, the short circuit impedance, it can be calculated by simply conducting a short circuit test. Suppose if we are calculating Z12, indicate that short circuited impedance into terminal 1 and 2. So see, Z12, that is Z suffix 1 and 2. So that means impedance between terminal 1 and 2. Where it is terminal 1 and 2? 1 is here, 2 is here. So impedance between these two terminals. या दोन टर्मिनल मधला काय आहे impedance आहे. So this impedance, it can be calculated with third winding, it can be kept open circuited. That is third winding, it can be keeping open circuited from that equivalent circuit, and we are able to calculate the impedance between these two. या दोन्हीच्या मधला impedance काय करू शकतो, calculate करू शकतो. That means suppose we are make short circuit here, this will be kept open circuited, third winding. If the third winding, it will be open circuited, that means there is a no current flowing from third winding because it is open circuited. Connection कसं येईल बघा. So हा one terminal to this two impedance, two terminal, again here 2 and 3 are short circuited. Sorry, 2 and this common point, it is short circuited, and one and common point, it is short circuited. So connection हे डायरेक्ट असं येईल. हा जो काय मिडलचा Z3 इम्पिडन्स असलेला जो काही वाइंडिंग आहे किंवा थर्ड वाइंडिंग, इट कॅन बी ओपन सर्किटेड. ही ओपन सर्किट केली, याच्यामधून फ्लो होणारा करंट काय असेल, 0 असेल. At that situation, we obtain the short circuit current. It will be flowing from these two winding. त्या दोन वाइंडिंग मधून शॉर्ट सर्किट करंट फ्लो होतोय. If we have calculated the short circuit current, that is ISC, and the short circuit voltage which is applied to conduct the test conduct करण्यासाठी जे अप्लाय केलेलं voltage आहे, this is the short circuit voltage VSC. If we taken a ratio of these two, that is VSC divided by ISC, we got the Z12 or the short circuit impedance between terminal 1 and 2. Similarly for other, okay, other साठी म्हणजे 1 आणि 3 मधला जर कॅल्क्युलेट करायचं असेल, at that situation we are keeping winding 2 or the secondary winding as a open circuited. Okay, so this is just calculated by conducting a short circuit test. That means impedance, it can be calculated by conducting a short circuit test. Similarly, this point is given here, that is Z12, it is nothing but summation of Z1 bar plus Z2 bar. Okay, see here. So if this tertiary winding or the third winding, it can be open circuited. ही third winding काय केले, open circuit आहे, म्हणजे इथं connection नाहीये. At that situation, the connection between these two winding to a common point. So supply, it can be given here. Impedance between these two terminals, Z12 impedance, that is Z12 bar, it is equals to impedance of this terminal or this winding and impedance of this winding, that is Z1 bar plus Z2 bar. Similarly, if we calculate the impedance of terminal 2 to 3, Z23, it is equals to Z2 bar plus Z3 bar, and Z13 bar, it is equals to Z1 bar plus Z3 bar. So because we have maintaining this as a open circuit mentioned केलं. So see, if we are Z12, it is nothing but short circuit impedance between terminal 1 and 2. Z23, it is nothing but short circuit impedance between terminal 2 and 3. And Z13, it is nothing but short circuited impedance between terminal 1 and 3. At that situation, remaining terminal or the remaining winding, it can be kept open circuit. त्यावेळेस आपण रिमेनिंग वाइंडिंग काय करतोय, ओपन सर्किटेड केप्ट करतोय. सो दिस इज रिलेटेड टू इक्वलंट सर्किट ऑफ द 3 वाइंडिंग ट्रान्सफॉर्मर. 3 वाइंडिंग ट्रान्सफॉर्मरचं इक्वलंट सर्किट आहे. सो ऑल द इम्पिडन्स which are calculated which is referred to one common base value. एका कॉमन बेस व्हॅल्यूला ते काय केले जातात, रेफर्ड केले जातात. दॅट मीन्स वी आर कन्वर्टिंग इट इनटू पर युनिट. So concept related to per unit, you people understood in the power system 3. So per unit value it can be calculated. So if the per unit value it can be calculated, there is a no change in the all other value of the circuit. Parameter remains same, just value it can be changed. It is nothing but we are considering one the base value, and according to that base value we are able to calculate the per unit value. Okay, see, solving equation above equation 1 and 2, that means 3.101 and 3.102, we got, if we solving this equation, we got a z1 value of z1 is nothing but 1/2 z12 plus z13 minus z23. So if we solve this all above 3 equation, जर हे तिन्ही इक्वेशन आपण सॉल्व केले, we got some of the value. We will solve here. See here, suppose we take addition of these two. या दोन इक्वेशन ची ऍडिशन केली, that is equation 3.100 and 3.102. So the equation becomes z12 bar plus z13 bar, it is equals to z1 bar plus z1 bar, that means 2 z1 bar plus z2 bar plus z3 bar. Okay, see, if you take an addition on the right hand side, z12 bar plus z13 bar. Okay, on the left hand side 2z1, I want to calculate the value of z1 at that situation. What is z2 bar plus z3 bar? z2 bar plus z3 bar काय आहे? See, the addition of z2 bar plus z3 bar, it is nothing but z23 bar, right? No, so that means we can represent here z12 bar plus z13 bar, it is equals to 2z1 bar plus z23 bar. Now shift the z3 bar into left hand side, it becomes minus, and 2 it is also shifted to the left hand side, it is nothing but 1/2. So according to this we got the value of z1 is equals to 1/2 z12 bar plus z13 bar minus shifted value, it is nothing but minus z23 bar. So similarly for other two, z2 bar and z3 bar. So we are able to calculate the value of impedance z1, z2 and z3. Okay, we are able to calculate the value of z1, z2 and z3. So see, the open circuit test can be performed on any one of the three winding to determine the core loss, magnetizing impedance and the turns ratio. Again, if we want to determine the core losses, we are able to that means calculate the core losses by considering or by doing the test, conducting a test, that is open circuit test. Open circuit test conduct करून आपण काय करू शकतो, calculate करू शकतो. Okay, so I think all of you getting, that is 3 winding transformer and equivalent circuit of 3 winding transformer. काय डाउट आहे का याच्यामध्ये? Is there anyone having any doubt regarding that? Just give me reply immediately.
No, sir.
Okay, so in this way we will conclude this today's lecture and we will stop here. In the next lecture we will take a next one point, that is Scott connection.